Hi and very good morning. My name is Nurul Ifa Betty Muhammad Najib Alaya Zakaria. My matric number is DE 200130.
Hi, my name is Nur Nazrin bin Nur Hisham. My matric number is DE 190138.
Hi, good morning, sir. My name is Muhammad Idham bin Muhammad Ashraf Effendi, and my number matric is DE 20065.
Hi, my name is Khairun Aisha Natasha with matric number DE200058.
Okay, I would like to present you about interaction. First, device generate an interrupt signal to notify the CPU that the device is ready to communicate with the CPU. After the CPU receives the interrupt signal, the data transfer will be echo. Data transfer will be initiated by CPU, but CPU cannot transfer the data unless the device is ready to communicate. For interrupt, we have two types, which is hardware and software. For hardware, interrupt occur when the signal is from hardware or external device. For example, clicking a mouse will generate an interrupt signal for the process to perform certain action. Last but not least, for software interrupt is caused by internal system of the computer. For example, access available memory or executing certain interaction can cause a software interrupt. Next, for objective, we have three, which is first, to study how the interrupt occur using memory. Second, to propose the hardware interrupt referring to a printer. Last but not least, to show how the interrupt in the printer device work. Now I would like to present you about the diagram, which is we using to CPU. For CPU, we have two our we have two output, which is the output and printer. For CPU, we have data and information. So in CPU, we should have RAM, HDD, and CD, and it can cause a memory. So this is diagram for CPU. Next, for flowchart, in using for printer, we should start and any data sent to printer. If you choose no, the process continues with other tasks. If you say yes, data for document to be print in sent to the buffer from the computer. So the content of buffer is empty to the printer. And next, which shows is the printer working normally, such as no paper jam. If you say no, an interrupt is sent to the user to request printer to be filled. If yes, the document is printed. Printer send the interrupt message to user to notify the document had been printed and is to be end.
Okay, for explanation of coding, first, sub, we want to adjust the return address before we save it, and then stmfd, stat return address, and then get the SPSR, and stat that a plus working register to. Now get the priority level of the highest priority active interrupt. Then move, get the interrupt controller base address. Then get the interrupt level 0 to 31. Now read, modify, write the SPSR to enable interrupts. Read the status register. Clear the 1 bit. Write it back to re-enable interrupts and jump to the correct handler. PC base address point to this instruction plus 8. Pad, so the PC index this table. Table of handler start address. Save other working register. Insert handler code here. Just add this code. And then for the LD and FD, we want to restore working register, not R12. Then now read, modify, write the CPSR to disable interrupt. And then MRS, read the status register, set the IB, write it back to disable interrupts. Now that interrupt disabled, can safely restore SPSR, then return. And then for restore R12 and get SPSR, restore status register from R14, return from handler, and then repeat the same process.
Okay, now I will present describe the contents. So in the describe the contents, it have two process interrupt. There is interrupt process 1 and then interrupt process 2. So for the interrupt process 1, I will explain the overlap printing and computing. When the printer ready, it will send an interrupt request, and then it will make the compute execution to be delayed, and the interrupt activity print to get control. Next, the print interrupt routine will implemented and returns from the interrupt. And lastly, it also have some with subroutine execution. So that is for the interrupt process 1. And then for the interrupt process 2, the compute will produce a set of lines of output. The print activity will alert and print this line. And then after done printing, one line printer will send interrupts request signal to the processor, and it will interrupt the execution of compute and control the print activity. So that's all for the describe the contents.
Hi, today I'm going to present about timing diagram and analysis. For the timing diagram, this is the most basic timing diagram for interrupt. We had made some research and we chose this timing diagram for our project. It shows that the normal operation of the interrupt controller. When the active unmasked interrupt line gets inserted, the internet sorting counter starts counting up from 0. The sorter is enabled for each cycle till the counter reaches 7. So basically, if interrupts are being input, the output waveform will change, and this is the most basic interrupt timing diagram. For the analysis, the purpose of our project is mainly to make a better understanding on interrupt. We had done a lot of research for our project, and we found out that printer is a simpler way to elaborate more about interrupt. We choose a past project, which is printer, because interrupt is basically a signal emitted by hardware or software which being sent to CPU for some event that need immediate response. So printer is a hardware interrupt. First of all, we choose the most suitable flowchart for our project, and this is the flowchart that we found. In this flowchart, there are two interrupts occur, which is any data sent to printer and is the printer working normally, such as no paper jam. This can be considered as interrupt. Then, after we create a flowchart, we choose the most suitable coding from past project and explain it using Mary apps. As Nasrin had explained to us, that is how the coding for printing devices and the interrupt that occur in a printing device. Lastly, during our research on this project, We found out that the interrupt has its own potential problem, which is stack overflow. This can occur because the return address and any additional context information is always added to the stack and interrupt use up stack space. If so, basically, if more information is being added to the stack than it can hold, stack overflow will occur. We hope that on the next project, researcher can lessen the rate of stack overflow that occur in these printing devices. That's all from me. Thank you.
Okay, for the conclusion, interrupts are an important part of the system as they provide the user better control of the computer. Without interrupt, a user may have to wait for the application they wish to use until he has a higher priority over the CPU to be run. Therefore, the use of interrupts allows the CPU to deal with the application request immediately. It also can increase the efficiency of our CPU. Next, it will decrease the waiting time of CPU so that we can do other work while waiting for it has to be done. Last but not least, it can stop the wastage of instruction circle so that it will be simply and easy to use. That's all for us. Thank you.
The unique feature of our project are the useful of interrupt where they allow the user to have more control over the computer. Without interruptions, a user may have to wait for a certain application to be assigned a higher priority over the CPU before it can be executed. This guarantees that the CPU will deal with the process as soon as possible. In Mary, SCPC, and SP, ISR is the interrupt service routines starting location stored in a special place in memory called the vector table.
Okay, so now for the Q&A, my question is at number 2, that is, what does current trend of computer architecture is relate with your project? So my answer is the current trend of computer architecture that related with our project is storage trend. This is because the parallelism in storage trend can provide alternative to faster clock in order to improve performance, applies all levels of system design, fascinating perspective from which to view architecture, and increasingly central in information processing. Hence, that is why interrupt processing can be related with the storage trend.
Our project can support the sustainable development through the storage trend. It is because the smaller the microprocessor, the higher the cost of manufacturing, the higher the performances, and finally all these factors can increase the sales revenue. Hence, the economy will be grown exponentially without compromising the capacity of future generations.
For the answer for question 4, the architecture trend can give a positive impact on sustainable development because of the increase in parallelism. Furthermore, parallelism also can increase the size of each level of hierarchy without increasing access time. In conclusion, parallelism can increase economic growth, thus, the right for future generations will be pursued and guaranteed.